Okay, so now we move on to the next part of our vector lesson. So we are going to learn about the scalar triple product. So let's see what is the scalar triple product. So a scalar triple product is a definite. I mean, the word itself says triple product, which means now instead of working with two vectors, you'll be working with three vectors. Okay, and then they say the scalar triple product has a very specific use. Now you saw when it came to the cross product, there was one very specific use that we had, right? What was it? We got the area. We were able to use the cross product to get the area of the triangles and area of parallelograms. Also, the cross product was used to find a vector perpendicular to both initial vectors. Now, in addition to that, we are now learning something called the scalar triple product. In scalar triple product, we say it can be used to find the volume of a parallel pipe. Okay, a parallel pipe and a tetrahedron. Okay, so first of all, what's a parallel pipe? A parallel pipe is actually now, you work with cubes, cuboids, right? Cube is all six sides are made with squares. Cuboid is all six sides are made with rectangles. So parallel pipe is a shape where all the six sides are made up with parallelograms. When all six sides are made up with parallelograms, then it's a parallel pipe. Do you see how it works? Can you see this figure, the parallel pipe? So it's kind of a slanted object because it's made up of parallelograms. So this the figure is given to you here. Do you see it? Okay, so then the scalar triple product is especially useful because we can find the volume of a parallel pipe by actually using the scalar triple product. So first of all, let me define what's a scalar triple product. It's given to you here. The scalar triple product is written as A dot B cross C. So you can see B cross C is the thing that we learned in the previous part, the cross product. So that we take it with the dot product of this A. So this, when you take it with the cross product along with another dot product, it becomes a scalar triple product. So to find the scalar triple product, the way we do is it's quite easy. First, let's define our vector A. Say vector A is made up of the vectors A1, A2, A3. And let's say B is made up of the values B1, B2, B3. And C is made up of C1, C2, C3. So then A dot B cross C, the way we find the value of this scalar triple product is again by using, like the previous section, we use the determinant of a 3 by 3 matrix, right? So here also I will be using it, the determinant of a 3 by 3 matrix. The only difference is now we don't use IJK. Now earlier for cross product, we use the top row was IJK. Do you remember? But now the top row will be the coefficients of A, the vector A, which is what? A1, A2, A3. The second row will have the coefficients of your B and the third row will have the coefficients of your C. So B vector is B1, B2, B3 and C vector is C1, C2, C3. And then as usual, we put plus, minus, plus. So the only difference between the normal cross product and the scalar triple product is in scalar triple product, you have an extra vector, the dot product vector which comes on top. So that is written as the very first row. And the other two cross product vectors will follow for the second and third row. Okay, is this clear? So then we can, you know how to find the determinant, right? You all know how to find the determinant. So then you can use the rule that we used previously and we can find the scalar triple product. So A1, if I just elaborate, then I get here B2, C2, B3, C3 minus A2, the modulus B1, C1, B3, C3. You know what I'm doing here, right? I remove the row and column with A2. Finally, row and column with A3 is removed. I get B1, C1, B2, C2. So I get here A1 into B2, C3 minus C2, B3. So actually, this is not very relevant. I mean, you need to do this with figures, okay? I'm just showing you B1, C3 minus C1, B3. Is that okay? Plus A3 times B1, C2 minus C1, B2. This is okay. So this is basically what, I mean, when we are working, we will be working with real figures here. So then we will put figures here and we will actually be able to, what our answer will come in terms of IJK now? No, our answer will directly be a very specific value. So because all of these are constants, you can simplify, you will get a very specific value. Is that clear? So let's do an example. Okay. So then we are going to get the modulus. We are going to find the scalar triple product of A dot B cross C. So we wrote the vectors. I wrote A in the first column, B in the second column, C in the third column, and I'm going to get the determinant of this 3 by 3 matrix. So you can actually skip this step if you are confident enough. Okay. What do we get here? 5 into 1 times 4 is 4. 0 times 1 is 0. Minus 2 times 1 times 4 is 4. 1 time minus 1 times 3 is 3. Plus into minus is minus 1 times. 1 times 0 is 0. Minus 3 times 1 is 3. So finally, I get here 4 times 5, 20. 4 minus 3 is 1. 1 into minus 2 is minus 2. Minus 3 into minus 1 is plus 3. So I end up getting 21. Then they also ask you to find B dot C cross A. So when you find B dot C cross A, what do we get here? B is so first here 1 1 1 and B dot C. So C should be 304 and A is 5 2 minus 1. So again we put plus minus plus and do the exact same thing again. Shall I do it immediately now? So what do we get here? Plus 1 times directly I'll write the bracket. Removing this row and column. 0 into minus 1 is 0. Minus 4 times 2 is 8. I'm doing it immediately, but if you want, I mean, you could do it manually. I mean, and then minus 1 times the second bracket. Remove the row and column with 1 0 to 1 1 1. What's remaining? 3 times minus 1 is minus 3 and minus 4 times 5 is 20. And last one plus 1 times, let's multiply 3 times 2 6 minus 5 times 0 is 0. So what do we get here? Minus 8 plus 23, right? Plus 6. So 23 plus 6 is 29. 29 minus 8 is 21. The next part, what are we supposed to find? This is Roman number 2, right? Part B. This is part B. Part C, what are we supposed to find? C dot A cross B. So when you do C dot A cross B, now the vector C should be written at the very top, which is 304. See, A is 5 2 minus 1 and B is 1 1 1. So make sure you put the plus minus plus. Three times 3 into 2. So 2 times 1 is 2 minus 1 into minus 1 is minus 1. And then next one minus 0 times. We don't even need to be bothered, right? Because the reason is we are multiplying anything with 0. It's entirely going to be 0 because of this 0 here. The last one plus 4 times. Remove the row and column with 4. 5 times 1 is 5. 1 times 2 is 2. So what do we get here? 2 minus minus 1 is 3. 3 times 3, 9. Minus 0. 5 minus 2 is 3. 3 times 4 is 12. So 12 plus 9 is again 21. So do you notice that all three answers are equal? All three answers for A dot B cross C, B dot C cross A, and C dot A cross B are equal. Is that okay? So then we'll write down this theory here. Write down the scalar triple product is cyclic. Do you see here? The scalar triple product is cyclic. So A dot B cross C, B dot C cross A, and C dot A cross B are all equal. So write it down. Okay, so then we'll move to the next part. So then they are describing here how the volume of the parallel pipe is actually found by the scalar triple product. So look at the parallel pipe they have drawn here. So in this parallel pipe, you can see they've taken the origin as this vertex at this particular vertex is taken as O, the origin, and the top vertex here they've taken as A, and this vertex they've taken B, and here they've taken C. Do you see? So the parallel pipe is actually made. Do you see that you have a parallelogram in the base? That's a base parallelogram, and then you have the basically now when we take the when we try to get the volume, what's the formula we normally use for volume? Volume is normally we how do we get the volume of and how do we find the volume of any 3D object like a cube or even this parallel pipe? We normally take the base area and multiply it with what? We take the base area and multiply it with what? With what height? With the height is correct, but there has to be a very specific height. Can't be slanted height. The height you are taking must be perpendicular height. Now you do see here the parallel pipe. Now you can see here the base parallelogram. Now if I say the base here, my base is the OBDC parallelogram. Do you see this is my base? So when I take the base area, because when we take volume is base area into perpendicular height, like a cuboid. So same theory here, base area is the area of the parallelogram. So that we can easily find, right? Area of the parallelogram is here modulus B cross C. Do you agree if I say it's modulus B cross C? Because it's a parallelogram, we take the full area. There's no half. Directly modulus B cross C gives you the area of this yellow color parallelogram. But then we need to multiply it with the height. Now the thing is, I have here the OA vector, which is a kind of like the slanted height. So I don't need the slant height. What do I need? I need the perpendicular height. So do you see they have marked this angle phi here, and they are getting the perpendicular height. How do we get the perpendicular height? Can you resolve? So how do we get the perpendicular height here? Can you resolve? The perpendicular height is, can you see? The OA, yeah, the A cos theta. Or we can say H is the OA cos theta. OA is the OA distance, isn't it? It's OA cos theta. So how do we write the volume then? Volume equals base area into perpendicular height. Do you agree? Base area into perpendicular height. So what's the base area here? Modulus B cross C directly, right? Modulus B cross C. And the perpendicular height is OA cos theta. OA means basically modulus OA cos theta, right? It will be A cos theta because modulus OA is the modulus of the vector A. Yes. It is okay. So this is the way we start this. Okay, now see. Okay, then now by using the definition of the dot product. Okay, so you have learned about the dot product in P4, isn't it? We learned the dot product. The rule was if you have A dot B, what's the way to expand the dot product? Modulus A, modulus B cos theta. Do you agree with me? Okay, so do you see that we have something quite similar to that here? You have modulus B cross C acting like A here, and modulus A acting like B here, and the cos theta. Actually, this should be cos phi, right? The angle here. Because the angle here H is cos phi. Okay, so anyway, do you see that I actually have the dot product rule here? Modulus A, modulus B cos theta is the A dot B. Likewise, the modulus B cross C into modulus A cos phi is actually what? from the definition of the dot product, do you see that this can be written as B cross C, B cross C dot A? So, or else we could say A dot B cross C, because both are the same, B cross C dot A, or we can say A dot B cross C, both are the same, right? The dot product, if you switch, it's okay. It's completely fine to switch the dot product. Okay, so A is the, I mean, do you see this rule? A modulus B cos theta is A dot B. Okay, so both of them are exactly the same. So this is A dot B cross C, and this is how the volume of a parallel pipe is found. Okay, do you see? Okay, so then let's move to the next part. Okay, then let's go to question number 3. Find the volume of the parallel pipe A, B, C, D, E, F, G, H, where the vertices A, B, D, and E have coordinates. So they've only given you the vertices that you really need. So A is 0, 0, 0. So A is basically the origin. B is 3, 0, 1. A, B, D is 1, 2, 0. And A, B, D, and E is 1, 1, 3. Okay, so how do we get the volume of the parallel pipe? You realize that the AB cross, now you need to realize here what's going on. Did you see what we did here in this particular question? Now when I explained you the definition, the B cross C here gave you the area of the base parallelogram, and then when you multiply it with the A dot. A dot is the OA, basically like the slant kind of height of the parallelogram, isn't it? Okay. So then we do the same thing here. So I get here the cross product of what? First I'll get the area of the base parallelogram, which is what? AB cross AD. Are you with me? AB cross AD. I get the area of the base parallelogram, and then I take the dot product with whom? AB cross AD gives me this particular person. And that I should take the dot product with whom? With AE. That's how the earlier the dot product worked, right? So this is the volume equation. Volume equals AE dot AD AB cross AD, or AD cross AB. This is clear? Okay, and then we yeah. So let's find the value here. The first thing you should do here is you must find the vectors AE, AB, and AD, isn't it? So what is AE? What's AB? Let's find AB. AB is B minus A, which is 301 minus 000, which is 301. Actually, A is acting like O here, right? So then we don't really need to find, but since they have given AB, AD, we'll find like that. AD is D minus A. So D is 120 minus A is 000. So 120. AE is E minus A. E is 113 minus 000. Now let's get the scalar triple product. AE is 113. AB is 301. AD is 120. And you use plus minus plus. So what do we get here? So first plus 1 times, shall I immediately find? Remove the row and column with 1. We get 0 into 0 is 0 minus 2 into 1. That's 2. Then the next one is this minus 1. We write the minus 1. Remove the row and column with 1. We get 3 times 0 is 0 minus 1 times 1, which is 1. And finally plus 3 times. Again remove the row and column with 3. Multiply 3 times 2 is 6 minus 1 times 0 is 0. So what do we get here? Minus 2 plus 1. 3 times 6 is 18. So how much do we get here? 18, 19. 19 minus 2 is 17. So this is the volume of the parallel pipe. Is this clear? Okay, then we move to the next part. We are going to discuss how to find the volume of a tetrahedron. Okay, so shall we discuss how to find the volume of a tetrahedron? So a tetrahedron is basically what? A tetrahedron is basically a triangular faced pyramid, a triangular based pyramid. So basically you have the base triangle, base is a triangle, and you have three other triangles to form the pyramid. Okay. So then how do we write the volume of a pyramid normally? What's the formula to write the volume of a pyramid? So volume of a pyramid is normally we write 1/3 base area into perpendicular height. Isn't it? Volume of a pyramid is 1/3 base area into perpendicular height, not just any height, perpendicular height. So then you can see here now the way they have marked the base is the OBC triangle. Do you see? Base triangle is OBC. So how do we get the area of the base? Basically, we take what? The cross product of the two vectors, C cross B. Do you agree with me? Or we can say B cross C. So if I take the cross product of the two vectors, B cross C, I get the area of the triangular base. Do you agree with me? So 1/3 base area is, B cross C is the area of a parallelogram. For triangle, what should we take? Half of B cross C. Half of modulus B cross C. Half of modulus B cross C gives me the area of the triangular base. Then the perpendicular height. So once again, for the perpendicular height, the technique we use is quite similar to the technique we used for the parallel pipe. You remember we want the perpendicular height. So what we did was we resolved the OA. Do you remember? So this height is, what is it? OA cos phi. OA in the sense it should be the OA distance. So modulus OA cos phi. Because I want this distance and the distance is resolved to get the height. Do you agree with me? So then I'll use here the height is into modulus OA is, in other words, what? It's actually modulus A cos phi, right here. So into modulus A cos phi. And then what do we do now? Again, we use the definition of the dot product. So what's the definition of the dot product? So say we have two vectors C dot D. C dot D is equal to modulus C modulus D cos theta. So here basically the B cross C is like the modulus C. The modulus B cross C is the modulus C. The modulus A here is like the modulus D, and the cos theta is also there. So this whole thing could be replaced as what? C dot D, or we could even say it's D dot C. Both of them are the same. D dot C, C dot D are exactly the same. Why? If you say D dot C, it's modulus D modulus C cos theta, right? Does the angle change? Okay. Okay, so basically C dot D by C dot D, I'm just using the same rule as A dot B. Okay, modulus A, modulus B, cos theta, I'm using the same exact rule. Okay, so then here, this is basically what? 1/3 into 1/2 is 1/6. This is A dot B cross C. Okay, A dot B cross C. However, there's one thing I do need to warn you about. Actually, when you take this dot product and the scalar triple product, now we are trying to get the volume. There are cases depending on whether you take B cross C or C cross B, you might get what answers? Negative, because you know B cross C is equal to negative C cross B. So if you take the product the other way, you'll end up getting a negative answer. So for these volume answers, at the end of the day, make sure your volume answers are what? Positive. Okay, so we need to fix that in both the parallel pipe and in the pyramid. So basically, you could write the area of the pyramid, area of the tetrahedron. This is the area of the volume of the tetrahedron. So the volume of the tetrahedron, make sure at the end of the day, you do give a positive figure here. And same for the volume of the parallel pipe as well. Okay. So question number 5, a tetrahedron has vertices A, B, C, D. So they've given you the vertices at this is your A, B, C, and D. So then they tell you, so A is 1, 2, 3. B is 4, 3, 4. C is 1, 3, 1. And D is 3, 1, 4. They ask you to find the volume. How do you find the volume? So what's the rule? Now we just now learned volume is equal to what? 1/6 of what? AD dot. So take one person as the height. So I'll take the base as the ABC triangle. So then we take the height from AD. So AD dot, what is it? AC cross AB, or you could say AB cross AC. Both of them are okay. Okay. And then end of the day, remember, if you get a negative answer, just take the modulus of it. Okay, so first things first, we have to get what? The AD vector, AC vector, and the AB vector. So who is AD? AD is D minus A. Get me D minus A. D is 3, 1, 4 minus A is 1, 2, 3. What do we get? 3 minus 1 is 2. 1 minus 2 is minus 1. 4 minus 3 is 1. Then AC vector is C minus A, which is 1, 3, 1 minus A is 1, 2, 3. 0, 3 minus 2 is 1, 1 minus 3 is minus 2. And then the AB vector is B minus A, which is 4, 3, 4. A is, so 4 minus 1 is 3, 3 minus 2 is 1, 4 minus 3 is 1. Is that correct? So then let's get the scalar triple product. So how do we get the scalar triple product? AD dot AC cross AB. So first start with AD, 2 minus 1, 1. Then go to AC, 0, 1 minus 2. And then AB is 3, 1, 1. And give the signs here, plus, minus, plus. So we get here 2 times. So I'm going to do it immediately. 1 into 1 is 1. 1 into minus 2, 1 into minus 2 is minus 2. Next, there's a minus mark anyway out. 2, 1 into 1 is 1, minus. Okay, so then we, okay, so then we get here minus, minus is already there, into minus 1 times, what do we get? Remove the row and column. 0 into 1 is 0. 3 into minus 2 is minus 6. Then plus 1 times, remove the row and column. 0 into 1 is 0, minus 3 into 1 is 3. So I get here 2 times 1 minus minus 2 is 1 plus 2, 3. 3 times 2 is 6. Minus minus is plus 1 into plus 6 is again 6. Last one, 1 into minus 3 is minus 3. Do you agree? 6 plus 6, 12. 12 minus 3 is 9. So so then let's input the volume. Volume equals 1/6 of AD dot AC cross AB, right? 1/6 into 9, which gives me 3 over 2. So the thing is, it actually depends on the way now you might be having questions like, is this the only way to use this? Like, can't we start it from any other vertex? Yes, you can. So actually, if you take now here, I took the point A and I took AD dot AB cross AC. So if you want, you can start even the volume equation. You could use you could get it from the B vertex. So you could go to BD dot, what is it? BC cross BA. You can do it like that because the scalar triple product is cyclic. Okay, so you can use, there are many alternative ways of doing it. However, end of the day, if you end up getting a negative figure, just make it positive, because now here, if I had used my cross product as AB cross AC, I would have gotten a negative figure as my answer. So if you get negative, then just take the modulus, because volume has to be positive. Okay, is this clear?